Hello, Algebra 2A, and welcome back to day 2 of our Lesson 40 video. Yesterday we looked at simplifying radicals and in some way how radicals are multiplied. Today we're going to look at how we can add or subtract radicals. And in order to add or subtract radicals, we need like radicals, radicals that have the exact same index and radicand. It's very similar to adding like terms. So if we have a 2x plus a 3x, we all know that when we have 2x plus 3x, that's going to equal 5 total x's. With radicals, if we have like a 2 root of 7 plus a 3 root of 7, that's going to equal 5 roots of 7. So again, if you have the exact same radicand, which we have a 7, and the exact same index, which these are both square roots, then you can combine these numbers that are in front to get one single radical. So those numbers in front we call the coefficients. So we can add the coefficients to get 5 root of 7. So we are going to take a look at example 3 and 4, looking at simplifying radical expressions, and then if possible, we are going to add together any radicals that we can. So we're going to head in and look at example 3. This problem is going to take me a little bit of room, so I'm going to rewrite the problem over on the side. So to add or subtract, we need to have like radicals. And we look here, we are going to try to subtract these, but 80 and 45 are not the same radicand. But not so fast. We're going to check to see, do 80 and 45 simplify? And because 80 has a factor of 16 times 5, and 45 has factors of 9 times 5, okay, 16 and 9 are perfect squares. Now the 8 out in front is multiplying that radical. So when I take 16, I'm going to square root it. It becomes a 4. That's going to take and multiply that 8 that's out in front. 8 times 4, and then I'm left with the root of 5. Next, I have a 12. When I square root that 9, it becomes 3. So that's going to be a 12 times 3 out in front, and then the root of 5 stays underneath. Now finally, I've got a 32 root of 5 because I can multiply the 4 and the 8. Minus 36 roots of 5, which is going to give me negative 4 roots of 5. So there's going to be my final simplified answer. So even though at first glance we looked at the radicands and they were not the same, we can simplify both of those if possible. We're looking to simplify them, and then we can get them to the same radicand of square root of 5. Looking at part B, we have a subtraction. At first glance, we've got a 18 and a 50, so they are not the same radicand. So as at this time, we can't add them together, but then we look to simplify. So 18 we worked on in day 1. That's going to be the result of taking 9 times 2, where 9 is a perfect square. And 50 is the result of taking 25 times 2. And when we square root that 9, it becomes 3, multiplies the 5. That makes the front of my radical 15. Roots of 2 minus square root of 25 is 5. 10. Roots of 2. 15 minus 10 is 5 root 2. There would be my final answer. So 5 roots of 2 would be the result of subtracting 5 roots of 18 minus 2 roots of 50. So again, at first glance, when you're looking at it, it does not have like radicals, but look to simplify and they will all work out and you will end up getting like radicals. Next, we'll take a look at what happens when we are adding radicals. And then one thing to notice, I changed the order around. This fourth root of 4 is a different index, so we cannot add it with the square roots. But we can take a look at square root of 32. That's going to be the result of 16 times 2, and 16 is a perfect square, plus the root of 2, and just know that there would be a 1 in front of that, and then plus 2 of 4 roots of 4. And 16 comes out as a 4, and it's going to multiply the 8, so that's going to make 32 root 2 plus 1 root 2 plus 2 fourth roots of 4. And we add 32 and 1 would make 33 roots of 2 plus 2 fourth roots of 4. And that is as much as we can simplify that one. So take a look at those radicands. You'll see some perfect square factors. Simplify those, and you are set to get your adding and subtracting going. To finish up lesson 40, we're going to look at A and B, just practicing simplifying again, similar to what we did in day 1. So we're going to take a look at the square root of y to the 6th. Remember, when we're taking a square root, we're looking for what number times itself equals back to y to the 6th. And with square roots, we can take that exponent of 6, cut that in half, and that's going to give us y to the 3rd. So that first answer there would give us y to the 3rd. Secondly, we're looking at the square root of 50, m to the 9th. Now 50 is not a perfect square, and then m to the 9th is not a perfect square. So hopefully you start to notice that when you have a square root of a power, that exponent has to be even to be a perfect square, and m to the 9th is not an even power. But we will rewrite this with our perfect square factors. So 50 is the result of 25 times 2. And then m to the 9th would be m to the 8th times m. So we'd have 25 times 2 times m to the 8th times m, and now we've got our perfect square of 25, and we've got our perfect square of m to the 8th. So perfect square comes out. Perfect square of 25 is 5, and m to the 8th is going to square root to m to the 4th. And then keep your leftovers underneath your square root symbol, which would be a 2m. So we'll continue practicing our simplifying expressions similar to day 1. And C and D, we will forego those. So when you're doing your practice, you'll be dealing with adding and subtracting radicals, but just with numbers, so that we can get a feel for how those problems work. We'll also forego example 5, so you are ready for your practice for today. Thanks for joining, and we'll see you next time.